Mechanical and Mechatronics Engineering at the University of Waterloo is shaping the future of the world, and you can join us. With the most advanced technology, materials, and state-of-the-art labs, Mechanical and Mechatronics Engineering is a trailblazing department, pushing boundaries to the limit in a vast array of disciplines. From nanotechnology to large-scale mechanical design to the biggest automotive research program in the country, thermodynamics, automation, fluid mechanics, and microelectromechanics. We're building the robots of tomorrow. We're tackling green energy, fire safety, biomechanics, and health engineering to make the world a better place. If you're looking for your calling, you've found it. Our programs are designed to produce skilled problem solvers, leaders, and innovators able to create mechanical systems and electromechanical designs that impact industries and the world. Take a leap into expansive undergraduate programs with the most exciting faculty at UWaterloo. Our interdisciplinary and collaborative degrees have amazing co-op and career opportunities for your future and offer the chance to work at the leading edge of research technology. Mechanical and Mechatronics Engineering postgrad studies offer endless research opportunities, grad scholarships, and fellowships. We offer programs for both researchers and industry professionals. Whether you want a master's or PhD emphasizing academic research, or a master's for working professionals. With strong industry partnerships and several Canada research chairs, our extensive network ensures your hard work gets noticed. And you can do it all immersed in one of the most incredible campus cultures in the country. At UWaterloo, you'll forge personal and professional bonds that will last a lifetime. Are you ready to shape the future of the world? Then join us.
Hi, my name is James Tung. I'm an assistant professor here in Mechanical and Mechatronics Engineering, and I'm here to tell you a little bit about our undergraduate programs in Mechanical and Mechatronics Engineering. So many of you watching this presentation are considering the Mechanical and Mechatronics program here at Waterloo, and what I'd like to do is highlight a few reasons why our undergraduate programs are so well valued around the world. One thing you'll see here in this slide on the right is a picture of our brand new building, Engineering 7 or E7. As you can see, it's a wonderful brand new building that houses some really excellent facilities and classrooms for our students. First thing I wanted to highlight was our department is the largest mechanical and mechatronics department in Canada, with 68 professors full-time with world-class expertise in some really exciting fields. So for example, my colleagues in additive manufacturing are creating new ways to produce 3D printed components. You can see a little picture of it here on the top left, where you see the MSAM, this really complex component. Our recently established RoboHub, a picture of it is here in the middle in the pink and purple, is the only multi-robot facility in the world with ground, aerial, humanoid, and maglev or magnetic levitation platforms in one place. It's a really exciting place to be. It's been highlighted in a number of interesting shows and documentaries as well. And our expertise also includes world-class researchers in autonomous vehicles, micro-electromechanical machines, green energy, and assistive technology, such as exoskeletons. So it's always a really exciting place to see, hear, and touch what my colleagues are developing to advance technology and our society at large. One of our big differentiators at Waterloo Engineering is our co-op education system. All our undergraduates in Mechanical and Mechatronics Engineering alternate between school and paid co-op work terms. Our students apply for real-world engineering jobs posted by the university on behalf of employers. And not only do students gain engineering skills and experience through their jobs, but they also exercise and gain confidence in resume writing and interviewing skills as well. And of course, these are paid positions. So the average salary work term for work term 6 students is $26.17 an hour, which roughly translates to about $52,000 a year. So these are well-paid jobs. As one of the founding principles at our university, our co-op system is well recognized, with over 7,100 active employers across 60+ countries. And I've listed some of our top employers here to the right, and these include major companies such as Apple, Tesla is another large employer of our mechanical and mechatronics engineers, Suncor, Toyota, so a lot in automotive as well. NVIDIA, which develops chips. So a lot of our mechatronics students are also engaged in doing hardware design for electronics companies. One of the nice things about co-op is that our students come back with real world experience and they make our learning environment a little more enriched as well. So when they come back and they tell their classmates about their experiences and how it relates to the course content, it's a wonderful thing because it really motivates our students to say, okay, this is material or content that is applicable in the real world environment. And they'll pay more attention and pay more spend more time in learning the content. We also have a creative, positive learning environment for our students. That's one of our main foci in our department. One differentiating factor is our cohort system, where students take courses with the same class of 90 to 120 students through the entire curriculum. So you stay with that same class throughout your stay here at Waterloo. And as a result, cohorts often stay in the same classroom, in fact, for lectures over the entire day. And the professors come in and out of that classroom, which really allows for a little bit more downtime between classes. We only have 10 minutes. It allows students to spend a little more time to find some food, chit chat, etc. Importantly, cohorts are really close-knit and they look out for each other over the course of their program, which I think is a real key in terms of getting through the program and helping each other out. As a department, we strongly promote experiential learning. This includes hands-on lab components to enrich classroom learning. We have capstone design projects and student design teams as well. You can see a picture of our engineering ideas clinic here, second from the left. And this space is used to facilitate these hands-on activities. So you can see here we have some test spaces here where we can test our projects in some challenging environments such as water or sand pits. And we also have capstone design projects for our fourth years. So this is an open-ended fourth year project done in teams over 2 terms. And it's really a culmination of the entire program. I'll tell you a little bit more about some of the projects that we've seen come out of the Mechanical and Mechatronics department in the past few years. We also have student design teams here. So these are extracurricular teams that engage like-minded students on particular projects. So for example, here in the bottom left, you see the aerial robotics design team, and they build and design aerial robots to compete against other universities, other teams from universities across the globe. We also have other design teams in rocketry. Solar cars, a really popular one, and I had one up called the biomechatronics team that helps design exoskeletons or prosthetics for those who need them. Kitchener-Waterloo is called a learning city because it has 2 universities, so Waterloo as well as Wilfrid Laurier, 1 community college, and 2 global research centers. And as a result, we have a very multi-ethnic, diverse community that includes a lot of cultural groups and services that are convenient to our students, or accessible to our students. So for example, one of the most challenging questions in my day is, what do I want to get for lunch? We have Korean, Chinese, Indian, Caribbean, all within a stone's throw. So it makes it for a really nice experience. Transit's also one of our really key features of our students. The Grand River Transit Pass is included in student fees. And we're also on the GO transit system. So we have convenient and affordable access to intercity transit. Waterloo has been ranked as Canada's most innovative university for almost 30 consecutive years for many reasons. A few of them I've listed here. Our department has had outstanding successes in entrepreneurship, largely stemming from the 4th year capstone projects I described earlier. Many 4th year teams have gone on to commercialize their projects into successful companies. And I've highlighted 3 here that have come from our department. So IntelliJoint Surgical, they've developed and delivered new tools to advance hip and now knee replacement surgeries and really making a difference in outcomes. ClearPath Robotics designs and builds ground robotics for industry. They're a really strong supporter of our program and really doing a great job in their market. And we also have North, which is formerly called Thalmic Labs, and they make high quality wearables, including smart glasses, which they launched last year. All 3 companies were founded by University of Waterloo mechanical and mechatronics engineers, and continue to support through co-op and sponsorships, etc. I hope this presentation offers you some insight into what makes mechanical and mechatronics engineering unique and really helps inform your choices. In case it helps, check out the Waterloo Engineering page on YouTube. I've selected a few videos here that highlight some of my departments and my colleagues' research labs and projects to help give you an idea of some of the exciting things that are going on here at Waterloo and that I hope you're part of. Thanks very much for your time. I hope you're doing well. Stay safe and healthy, and hope to see you soon.
Thank you so much for watching the first part of our presentation. We're now going to go into the Q&A session. If you have any questions, please do type them in using the tab on the side of your screen, the Q&A tab. We have people there live ready to answer those questions through typed responses. We've also got two of our wonderful professors here today to answer some of the questions that we've received. Allison, could you introduce yourself, please?
Hi, my name is Allison Janakoris. I'm a lecturer in Mechanical and Mechatronics Engineering. I primarily teach the mechatronics students in first, second, and third year.
Wonderful, thank you so much, Allison. And Kamyar, could you introduce yourself, please?
Hi, my name is Kamyar Gavam. I'm a lecturer in Mechanical and Mechatronics Engineering department, and I teach undergrad and graduate courses both to mechanical and mechatronics students.
Great, thank you so much. Now let's get started with the questions. The first question is, what is the main difference between mechanical and mechatronics engineering? Kamyar, maybe we could start off with you, and Allison, I'd love to hear from you as well.
I always have this definition. Mechanical students make machines. Mechatronics students make smart machines. So mechatronics students know how to make machines and how to make them smart. Like, for example, consider the robot itself. The mechanical students know how to design a robot, for example, find all the velocities where they can actually reach. But mechatronics student can control it as well. So I define it, the difference as this way.
Excellent, thank you. And Allison, can you give us your definition?
So I usually say that mechanical design digs into the details of the physical system. What materials are we going to use? How are we going to assemble it? How can we analyze this? Whereas mechatronics dives into other elements of the robotic design as well, such as bringing in electrical systems, both the hardware being the circuitry, how do you control it, what sensors are we going to use, what wiring, as well as the software to actually tell it what to do.
Excellent, thank you, Allison. Now, I've heard that there is a mechatronics option in mechanical engineering. Kamyar, could you explain that a little bit more? What does that mean for students if they wanted to take the mechatronics option?
Yes, we have several options in mechanical engineering program. For example, we have the part which is related to biomechanical, the other part which is related to welding, and there is an option for mechatronics as well. So if you get into mechanical program and after a couple of years you notice, oh, I liked mechatronics more, so you can actually switch that option and take the courses related to mechatronics. So that it's a good news for the mechanical students that they can take another path.
Okay, that's awesome. And Allison, which design teams can students join as mechanical or mechatronics engineering students?
So all 21 of our design teams are open to students from all engineering disciplines. That said, there's some that are more popular with our mechanical and mechatronics students, particularly those around robotics, vehicles, our aerial robotics team, but students are welcome to join whatever interests them.
Okay, that's fantastic. And in addition to design teams, are there clubs or other extracurricular athletics, things like that, that students can get involved with?
Absolutely. There's plenty of clubs run by the student union at the university level. There's athletics at the university level, as well as just more casual intramural sports. And there's also department level clubs that you can look into.
Oh, fantastic. That's great. We had a couple of questions come in about programming languages. So I'm wondering if both of you, maybe we can start with Kamyar, if you could tell us what languages are taught in mechanical engineering and then also in mechatronics engineering.
I know that the students learn C++ in mechanical program. Also, in 2 of my courses, I asked the students to write codes in MATLAB. And so they can learn both. But in general, if you learn one of these languages, it's very easy to learn the other languages as well.
Okay. And Allison, in mechatronics engineering?
So our mechatronics students start off in first year with learning C++ and Robot C. In later years, they'll also take some courses where they will use the C programming language. But as Kamyar mentioned, once you've got a good grasp of one language, it's quite easy to pick up the others.
Okay, wonderful. And I'm wondering if you could speak a little bit about labs and how labs have been running currently online right now as we're in the pandemic. So a lot has had to take place online. Could you tell us a bit about what that experience is like for students?
So we've definitely had to make some changes to our labs. Obviously, having everybody in the room, hands-on touching components isn't going to work right now. For some of our labs that involve large industrial equipment, we've been able to take videos of the lab in action, provide students with data and allow them to do the analysis. For other labs, such as my electronics courses, we've been able to leverage online simulators so that students can still get a feel for working with the components. Although it's not quite as good as physically being able to build it yourself, it's the next best thing, and it still gives them the experience they need.
That's great. And Kamyar, could you speak a little bit about what the online lectures are like and how you've been managing that during the pandemic?
So it depends on the professor. I myself, I make pre-recorded videos. I post them to YouTube and share the YouTube link with the students. The good thing about this, they can actually watch those videos on their own time. And then I hold office hour sessions, which are live every week. So the students can attend at a specific time through the WebEx meetings or Zoom meetings. Mine is WebEx. And they ask their questions if they have any, and I solve more examples for them. So it's a combination of live sessions and pre-recorded videos.
Okay, excellent. I did get also some questions about co-op. So I wanted to ask a little bit about co-op and how that process works for students. One of the students was asking about travel opportunities. So can you tell us, are students able to travel for co-op roles? You know, I know there's limitations right now, but in normal times, are they able to accept jobs abroad?
Who doesn't like to travel, right? Yes, this is why actually many of the students choose the options, the companies which are outside of Canada. For example, many of the companies in Silicon Valleys, specifically for our mechatronics students, like Apple, like Google, or even Tesla for our mechanical and mechatronics students. And not necessarily just in the States, they go to other countries like China or any European country. It depends if they can get a proper job in one of those countries, in one of those companies abroad. But yes, definitely there will be an option to travel, hopefully soon after this pandemic.
Okay, wonderful. And do many students find their own co-op placements? I know there's a system called Waterloo Works, but are students finding placements outside of Waterloo Works on their own?
They will find, so we have actually a number for that statistically. Every single term, for a co-op term, about 99%, 98 to 99% of our students can secure a co-op job. Those students who cannot find a co-op job, they can actually work in one of our research labs under supervision of one of our professors and work on one of these top-notch and cutting-edge research activities and programs.
Allison, what would happen if a student wasn't able to find a co-op job in a term?
So our students only need credit for 5 of the 6 co-op work terms to graduate. That means that something might, if you're unable to get a job in that first work term, or if you choose to take a term off later on for personal reasons, that's okay. You can still graduate on time. That first job is always really hard to get, no matter where you're getting it. So, and especially with the current pandemic situation, if you find yourself unable to secure a job for that first work term, there's other options such as looking into working in a research lab with a professor, or working on a side project you're passionate about and building up some skills to help you secure the job you really want the next term.
Okay, that's wonderful. And can you explain some of the industries that MME students often get co-op jobs in? We've had a lot of questions about the aerospace industry. Do you see a lot of your students getting co-op roles in that industry? And what are some of the other spots that they're working?
So my answer to that question is always, what industry would you like to work in? Name an industry, and I can probably name a company where some of our students have worked. Aerospace was asked specifically. Absolutely, our students have worked for Boeing, Lockheed Martin, General Dynamics, as well as plenty of companies that support Boeing and companies like that.
Awesome, that's fantastic. So I have one more question for both of you. And as the students are applying to Waterloo Engineering, do you have any recommendations for them? What are some things that they might want to include and some information that they might want to share about themselves when they're going through the application process? Do you have any tips related to that? And Allison, maybe we'll start with you.
Sure. So the first thing I would say is if you took any AP or IB courses, that's a great place to make note of them. It's also a great place to share what you're passionate about. Even if it's not directly related to the field of engineering you're applying for, that's okay. We're looking for well-rounded students, and that means any previous work experience, volunteer experience, responsibility looking after siblings, helping out your grandparents. All of that is important, and they're great things to put on there.
Great, thank you, Allison. And Kamyar, do you have any tips for the students who are going to be applying?
I echo what Allison mentioned here, and just to add to that, any work that you've done, for example, you've worked at McDonald's, that's great, because because at the end of the day, you have to go and find a co-op job, and they want to see that you did a real job and you took that responsibility. So it's a plus. So please add any extracurricular activity that you did, and any job, even the voluntary job that you did, add them in your resume.
So Allison, could you tell us what is the average number of students in a first-year class for mechanical and mechatronics engineering?
Yeah, so every year we have 2 classes of mechanical students and 2 classes of mechatronics students, and each class has about 100 to 110 students in it.
Fantastic. Thank you so much, Allison and Kamyar, for answering all of those questions. Thanks and have a great day.